Lesson 7.2, Task 1. So in the last section, we talked about recursive formulas, and this time we're going to look at explicit formulas. We're still looking at an arithmetic sequence, so that means you add or subtract to get to the next term in the sequence. All right, so it says write and use explicit rules for arithmetic sequences. In the previous lesson, you wrote recursive rules for arithmetic sequences. In this lesson, you will write explicit rules that describe how to find the nth term of a sequence. An explicit rule for a sequence defined by the nth term of the sequence as a function of n. For instance, an explicit rule for an arithmetic sequence 5, 15, 25, 35 is f of n equals 5, which is your first term, plus n minus 1 times 10, which is your common difference. And n minus 1 means like your previous term. All right, so the first several figures in the pattern are shown below. So figure 1 is 1 square, then you've got 3, then you've got 5, and then the dot, dot, dot again shows you that the next 4 or 5 are not here. This is just like the general form that they want you to look at. Okay? All right, so it says let S of n equal the number of squares in the nth figure. Which statements about S and n are true? Select all that apply. All right, so if we are calling the pattern above S of n, then let's see what it says. The sequence defined by S of n is an arithmetic sequence. 1, 3, 5. I'm adding 2 each time, so yes, that is an arithmetic sequence. It has a common difference. Consecutive terms in the sequence do not have a common difference. That's not true. The common difference is 1. From 1 to 3, you add 2. From 3 to 5, you add 2. So the common difference is 2, not 1. All right, it says the table shows S of n expressed as the sum of the first term and a multiple of the common difference. Complete the table of values for n from 1 to 6. All right, so your first term is 1 plus 2 times the previous term. 2 is your common difference. So that gives you 1. And then you're just going to go 0, 1, 2. And this is the term that you're putting in. See, S of n? So n is the term, the previous term here. All right, so it's going to be 1 times 1 plus 2 times 3. Okay, and that equals 7. And then 1 times 2 plus 4. And 1 plus 2 times 5. All right, so you just continue that pattern. Oh, shoot. I cleared it instead of checked it. Okay, 2, 4, 5. All right, there we go. All right, now it says generalize the results from the table. Complete the blanks to write an explicit rule for S of n and use the rule to find S of 13. All right, so the first term, okay, is 1. So I'm going to put a 1 here. And then plus n minus 1. That's your previous term. That just states the previous term times 2. So to find S of 13, we can just use the rule. So S of 13 equals your first term plus 2 times the previous term. If we're looking for term 13, the previous term is 12. So 1 plus 24 or 25. So S of 13, our 13th term is 25. And that's just using the rule that we found above. All right, so your general explicit rule for an arithmetic sequence, an explicit rule for the nth term of an arithmetic sequence with a common difference d is given by f of n equals f of 1, your first term, plus n minus 1, your previous term, times d, your common difference. 7.2, Task 2. Write and use explicit rules for arithmetic sequences. An arithmetic sequence is defined by the explicit rule f of n equals 12 plus n minus 1 times 9 for all values of n between 1 and 10. What is the first term of the sequence? All right, the first term comes from this number right here. So the first term is 12. And then it says, what are the domain values for the function? Well, it says all n between 1 and 10. So we're going to do numbers between 1 and 10 for my domain. And then it says, what are the range values? All right, for the range, you're going to substitute 1 into the formula. 1 minus 1 is 0, so that would just be 0 plus 12. So 12 will be the starting point of your range. And then plug 10 in. 10 minus 1 is 9. 9 times 9 is 81. 81 plus 12 is 93. So our range goes from 12 to 93. And you can write that out if you can't do that with mental math, but hopefully you understood what I did just there. If not, please let me know. All right, an arithmetic sequence is equivalent to a linear function with a restricted domain. Fill in the blanks to show that the explicit rule for the sequence can be written as a linear function of the form f of n equals mn plus b. All right, so let's look at what we have here. All right, so we're going to look at it as slope-intercept form. Y equals mx plus b. That's basically slope-intercept form, just written with different variables and in function notation. All right, so we want to write this formula in this format. So we've got 12 plus, we got to fill in these blanks. So let's just simplify it a little bit. So if I've got 12 plus n minus 1 times 9, I can distribute the 9 inside the parentheses. So I'm going to have 12 plus 9n minus 9, because negative 1 times 9 is negative 9. And then I have 9n, and then I have 12 and minus 9 can be combined because they're like terms, so plus 3. So f of n equals 9n plus 3. So this is now in slope-intercept form. All right, so right here, we need to fill this in. So 12 plus blank n, so that's the 9n here that they want. 9n minus 9. Okay, so that comes from this row right here. 12 plus 9n minus 9, and that equals 9n plus 3. And now that is written in slope-intercept form. All right, that's all for task 2. If you have any questions, please let me know. Lesson 7.2, task 3. Convert between forms of arithmetic sequence. Every arithmetic sequence can be described using both recursive and explicit rules. Group admission is $30 for the first person, $11 for each additional person. The photo shows the cost of admission to the aquarium for a group. Let f of n equal the total cost in dollars of n admission tickets. All right, what are the first 3 terms of the sequence defined by f of n? So the first term is 30. And then we add 11 to get 41. And we add 11 to get 52. So that would be the first 3 terms. All right, choose the number that correctly completes the explicit rule for this sequence. All right, so the explicit rule is a little bit different. So we got to think about n minus 1. So what would be the n minus 1 term? So if this first term is 30, the n minus 1 term would be 11 before that. So if I subtract 11 from 30, I get 19. And then my common difference is 11. And that's my explicit rule. So it's very similar to the other rule. All right, f of 1, my first term is 30. This is the recursive rule. And then the previous term, which we set up here, was 19. So you got the previous term plus 11 for all numbers, all n greater than or equal to 2. All right, so basically this line right here, if we don't have that this first term is 30, we can write the previous term as 19, and that's the only difference here between the explicit and the recursive formula. All right, it says, what is the cost of 20 tickets? All right, so let's look at the cost of 20 tickets. All right, I'm going to say my rule is f of n equals 19 plus 11n. All right, and the question says, what is the cost of 20 tickets? All right, so that means n is 20. So we're going to do 19 plus 11 times 20. All right, so that equals 239. So 20 tickets cost $239. Which rule did you use to find the answer? All right, so I used the explicit rule, because with the recursive rule, remember, you just have to add the common difference until you get to the term that you want, which you can do that, but to go to the 20th term, that would take a few minutes to do that, and then if you miscount and you did 19 or you did 21, you may be off just a little bit and get the wrong answer. So the explicit rule is very helpful when you're looking at terms that get more than just a few away from what you started with. All right, let's look at this turn and talk. This is a good question. All right, it says how many tickets can be purchased for $294? So we have this explicit rule, f of n equals 19 plus 11n. This time they're giving us the amount, so that goes for f of n. So you can substitute 294 equals 19 plus 11n, and you can solve for the number of tickets. So if I subtract 19, I get 275 equals 11n, and divide both sides by 11. So n equals 25. So when n equals 25, or when I sell 25 tickets, that's going to cost $294. All right, that's all for task 3. If you have any questions, please let me know.